Okay, so welcome to section 1.3. It's trigonometry with respect to the coordinate plane. So trigonometry. With respect to, WRT, with respect to, you can find that on your symbol sheet, the coordinate plane. Coordinate plane. Okay, so let's recall. So the vertex, where was the vertex? So the vertex is the point. Vertex. That was the point where the two rays of an angle met, right? So the vertex of an angle is the point where the two rays defining the angles coincide. Is the point where the two rays defining the angle coincide. Or actually, let me just say meet. I think you understand that. Okay, so definition. Okay, so an angle is in standard position. So an angle is in standard position. So that's what we're defining, standard position. Standard position. If its vertex is at the origin. So if its vertex, and I'll draw a picture in a moment, is at the origin, and the origin is the point 0, 0, i.e. 0, 0 in the coordinate plane. 0, 0 in the coordinate plane. Coordinate plane. And its initial side is flush with the positive x-axis. And its initial side is flush with the positive x-axis. With the positive x-axis. Okay, so what do I mean by that? So for example, e.g., let's say we have the x and y coordinate axes. So x and y. And I'll just draw it like so for the time being. Usually I would draw it for all four quadrants, but let's just do it like this. So we have the x-axis. So what we mean here is if we have a ray in purple, and let's call this point A, and we'll call the origin point B, and then I have another ray going off like so, say through point C. So what I've created is an angle theta here. Oops, let me draw that a bit better. So notice the initial side, where we start measuring the angle in counterclockwise direction. So initial side BA is along the positive x-axis, right? Positive x-axis. Vertex B is at the origin, 0, 0. meaning where the two axes, the x and y axes, cross. So this is an angle in standard position, so we would say theta is in standard position. So theta is in standard position. Okay, so that's the illustration of an angle in standard position. So for example, let's see, where shall I put this? Here. So example, let's find the equation of the line through the terminal side of angle theta pictured below. So find the equation of the line through the terminal side. Remember, the terminal side would be like the blue guy up here. Through the terminal side of theta pictured below. Okay, so let me draw the picture. Pictured below. So let's go ahead and draw our x and y coordinate axes. 1, 2, 3, 4, 5, something like so. So we have our x, and let me bring this down a bit, and y axes. So 1, 2, 3, 1, 2, 1, 2, 1. Okay, so let's say I have a line that goes through something like so. Yeah, okay. So this is my line, and I want that theta in standard position is measured from the positive x-axis. Okay, so what do I know? I know that the point, I have a point on this line at -1, 3. I also have the point 0, 0 on this line, agreed? So we have 2 points, -1, 3, and then we also have the point 0, 0. Let me do this in a lighter pink. 0, 0. So 2 points using the point slope form of a line. First, we find the slope. So the slope of a line, if we're given 2 points, is going to be the change in y. So that's y2 minus y1. So y2 minus y1. That's the rise over the run is going to be x sub 2 minus x sub 1. So x sub 2 minus x sub 1, rise over run. Okay, so what do we get? So for us, the second y coordinate, which I had in hot pink, is 3. The second x coordinate is -1, so I'll put that in the denominator. Then on the top and bottom, we subtract. And the first y coordinate is 0. First x coordinate is also 0, so that's nice. 0 is a lovely number, my favorite number. So 3 divided by -1 is -3. So that's the slope. So now we can do the point slope form of a line, which is y minus y given. Let's go ahead and use the easy one. Y given in this case will be the lovely 0, which I like so much. That's going to be equal to slope m times the quantity, x minus x given. And once again, I'm using this point 0, 0, so let's go ahead and plug in. So we will have y minus 0 is equal to slope -3 times the quantity, x minus 0. Okay, so 0 is a lovely number. So the equation of the line with terminal side for theta is going to be y is equal to -3 times x. And that is that. So this is the equation of the line. which has, oh wow, why will this not work? Let me draw a box. No, okay. Clearly this app does not want me to draw a box. Okay, there we go. That is the equation of the line. Okay, holy free holy. Okay, so let's recall. So given triangle ABC, so given triangle ABC with opposite sides, little a, little b, and little c, respectively. So with opposite sides, little a, little b, and little c, respectively. And I'll draw this in a moment, respectively. The Pythagorean theorem. The Pythagorean theorem. Theorem states that if the measure of angle C is 90 degrees, then, okay, so let me first draw the picture and then we'll answer the question. So triangle ABC. So we want that the measure of angle C is 90 degrees, so we'll put the symbol for 90. So let's have A with opposite side A, vertex B with opposite side little b, and vertex C with opposite side the hypotenuse little c. So the Pythagorean theorem states that c squared will be equal to a squared plus b squared, right? So we have c squared is little a squared plus little b squared. That is the Pythagorean theorem. So hopefully everybody's comfortable with that. Okay, so let's consider then, do I have enough space? No, I'll go down to the next page. So let's consider an angle in standard position. So consider maybe I'll have enough room. I'll put it up here. So I'm going to draw x and y coordinate axes. So x and y. And let's have an angle somewhere here. Okay, so our angle will be theta in standard position as measured from the positive x-axis. So what I'm doing is I'm going to create a triangle here. And notice now my right angle is over here for that angle theta in standard position. And let's call this point here point P, x comma y, whatever that may be. Okay, so that would mean that, no, do you know what? I want to color code them. Let me color code x. So for x, let's have it be orange. No, I already used orange. Okay, let's use gold for x. X, so the length here for the bottom is x. And let me draw that in yellow. Okay, and then comma. Well, the height, I already put purple for my height. So I will use the height y here is purple. So we have this point at x comma y. And I'd like to find what I'm going to call now radius r. Well, radius r is the same thing as hypotenuse c. So I claim that r squared is equal to the sum of the squares of the lengths of the other two sides, namely x squared plus y squared. So that would be the Pythagorean theorem on this triangle in this orientation. So if I wanted to solve for r I would just take the square root of both sides, the positive square root. And the reason I take the positive square root is because it's a distance, and there's no way for a distance to be negative. So normally when you take a square root, you would do plus or minus, but this is distance. Distance is always positive, even if you go in reverse. Okay, so there we are. So r is the square root of x squared plus y squared. So notice that theta is in standard position, so we're okay. Okay, so definition. Definition. I hope that wasn't too cramped, by the way. Hope you guys can read that. Definition. Okay, so let's let P, so let point P at x comma y be on the terminal side of an angle theta. So B, actually not B, and let's write lie on the terminal side. Terminal side of an angle theta, and angle theta in standard position. Standard position. So basically exactly what I have above. So this point P lied on the terminal side of the angle theta in standard position. So, and let r be equal to the square root of x squared plus y squared, be the distance from the origin to point P. So be the distance from the origin, which we can see it is, to point P. Okay, so then we have the following. I'm going to do a whole bunch of definitions now. These are the trigonometric functions. Okay, so let's do first definition, sine, S-I-N-E, sine of theta. So that's what we're defining, S-I-N-E of theta, denoted by just simply S-I-N theta. So S-I-N theta, or sine of theta, is y divided by r. So sine of theta is y over r. The next trigonometric function is cosine of theta. So cosine of theta, denoted cos of theta, is going to be x divided by r. And then the next definition will be tangent of theta. So we're defining tangent of an angle theta, and that's denoted tan of theta. That's going to be y over x. So notice that that would be the quotient of the two above because I can reduce the r's. So there's a reason I do this in the order I do. So the next three definitions would be cosecant of theta. So cosecant of theta, denoted, and we have to be careful how we denote these. This is CSC, not COS. So cosecant of theta is different from cosine of theta. And cosecant is going to be r over y. Notice that that's just sine upside down. That's interesting. Okay, so the next one will be secant of theta. Secant of theta. So that's going to be denoted SEC of theta, and that's going to be r divided by x, which is cosine upside down, or the reciprocal to cosine. And finally, let's do cotangent of theta. And that's going to be denoted, so we have to be careful again, denoted COT. Oh, that's a terrible C. COT of theta. Now notice we have three guys that begin with C, so we have to be careful. One's cosine, one's cosecant, and this is cotangent. Cotangent is going to be x over y, which looks like the reciprocal to tangent. Okay, so let's note. I keep on saying this, so let's note it, shall we? So let's note exactly what I was saying. So, how shall I do this? So sine of theta, pardon me, was y over r. But when I flip that upside down, I got cosecant of theta being r over y. Let me do purple for cosine. So cosine of theta we had given as x over r. But when I flip that guy upside down, I get a secant of theta is r over x. Then finally, let's do tangent of theta, which is y over x. Notice it's just the quotient of the two above it. And if I flip that upside down, the reciprocal to tangent is cotangent of theta, which gives us x over y. So if we understand the reciprocal functions, and note something, that s's and c's go together. So the reciprocal to anything that begins to s is a c, and vice versa. So actually I could probably still use the same color. So notice c here and s here. Okay, that's just a mnemonic device. Okay, so for example, so find the 6 trigonometric functions of theta. So find the 6 trigonometric functions. No metric functions of theta. Corresponding to the point. Corresponding to the point P at, let's see, what should we do? 5, 12 through the terminal side of theta. Through the terminal side of theta in standard position. In standard position. Okay, so what do we have? We have the point 5, 12. So what does that give us? That gives us that x is 5 and y is 12. Okay, well, in order to find the 6 trigonometric functions, I would need to find the radius r. But to find the radius r, I can use the Pythagorean theorem. So let's go ahead and do that. So I know that r squared, or r, will be the square root of x squared plus y squared. Agreed? So that's going to be x squared plus y squared. But those who are savvy with their Pythagorean triples should already know the answer. So this will be the square root of 5 squared is 25, and 12 squared is 144. So that's going to be the square root of 169. And that's 13. So this is a 5, 12, 13 right triangle. So let's note. So note this is actually 5 was in blue, so a 5 12 13. 12 13 right triangle, and this is called a Pythagorean triple. So let me just call it that. Pythagorean, much like 3, 4, 5, Pythagorean triple, meaning it makes a right triangle. Okay, so let's get started. I used the wrong colors. Oh well, then I'm sticking with this color scheme. Okay, so first we want sine of theta, which we know is y over r. Okay, so for us that's going to be 12 over 13. Actually, maybe I should move this down a little bit so I have more room. Okay, so right away I can find the reciprocal. So since sine begins with an S, his reciprocal begins with a C. So that's cosecant of theta will just be the reciprocal. So it's going to be radius 13. Actually, let me write it r over y, which for us will be 13 over 12. Okay, so cosine of theta is x divided by r, which for us will be 5 over 13. Okay. So now the reciprocal to that, since cosine begins with a C, his reciprocal begins with an S, so that's secant of theta. So that's going to be r over x, which is 13 over 5. So r over x is 13 over 5. Okay, last but not least, tangent. So what's nice about tangent is I don't have to think. So tangent of theta, which is going to be y over x, I just look at the two guys right above it. I notice there's a 12 and a 5, and the 13s will reduce. So this just becomes 12 over 5. 12 over 5. And the reciprocal to tangent is cotangent. So cotangent of theta, which will be x over y. X over y is just the reciprocal of what I just put. So instead of 12 over 5, we have 5 over 12. 5 over 12. Okay, so there we are for that one. Let's see. Don't know if I have enough space. So, yeah, I don't have enough space to do another example on this page, so let's continue up. Hopefully everybody understands that. So for example, should I do an example first? So no, let's recall, because you might need to recall. So let's recall. The plane, not just any plane, the xy plane. Let me make that evident. The xy plane is broken up into 4 quadrants. Let me write out the word for 4 quadrants. Okay, so what are the 4 quadrants? Quadrant 1, capital Roman numeral 1, is in the northeast corner. Quadrant 2, Roman numeral 2, is in the northwest corner. Quadrant 3, it's a terrible 3. Quadrant 3 is in the southwest corner. And quadrant 4 is in the southeast corner. Okay, so let's consider, before I do an example, I want to consider, consider so let's do X and Y coordinate axes. So X and Y. So the way we name these is quadrant 1, which we'll call Q1, is in the northeast corner. Then quadrant 2, which we'll call Q2, is in the northwest corner. Quadrant 3 is in the southwest corner. And quadrant 4 is in the southeast corner. So notice we name the quadrants in the counterclockwise direction, much like we would measure an angle theta. Okay, so let's consider a point in each quadrant. So if I have some coordinate x, y in quadrant 1, then the SIGNs corresponding to them, they're both positive. I'm on the right-hand side for x and above the horizontal for y. So they're both positive here. Whereas if I had a point in the second quadrant, x, y, I'm on the left-hand side for x, which means I'm negative for x, but I'm still above the horizontal for y, so that's positive, going upwards. So now let's have a point in quadrant 3. So x goes to the left of the origin and y dips beneath the origin. So since they're both in their negative regions, their signs are negative and negative, SIGNs. Similarly, if I have a point x, y in quadrant 4, well, I'm to the right of the origin for x, so that's positive, but I'm beneath the origin for y, so that's negative. Okay, and we'll come back to this in a moment, but let's do an example. So example. So determine which quadrant, so determine which quadrant the terminal side side of theta lies in, so given that sine of theta is negative 3 over 5 and cosine of theta is going to be positive 4 over 5. Okay, so what do we have? We have that sine of theta is negative 3 over 5. And there's a reason I put the negative on top. This is going to be x over r. And remember, the radius can never be negative. So from this we know that x is negative 3. Then we're given that cosine of theta, cos, is going to be 4 over 5. That's a terrible 4. 4 over 5. So that's going to be y. What am I doing? Why did I put x here? Oh my goodness. Oh my goodness. Don't listen to me. Do as I say, not as I do, clearly. Sine is y. So y is negative 3. Cosine is x. Boy, I wrote it down. Didn't read it. Okay. And much like the complementary and supplementary angles, C comes before S. So complementary angles are 90, supplementary angles are 180. The same thing can be said for cosine and sine. Because C comes before S, X comes before Y. So I should have known that. Both C and X come before S and Y respectively. Okay, so everything's in order in math. So I must be tired. I'm trying to quit caffeine. See what it does? Should never quit. Okay, so now Y is negative 3, but X is 4. And we already had that the radius was 5, but that's not going to come into play here. And that's because, what are we looking for? We're looking for the quadrant. We're looking for the point. The point x comma y in our case is going to be where? Okay, well, x is purple, and x is positive 4. Y is blue, and y was negative 3. So that is, I have a positive x value and a negative y value. So which quadrant is that in? Well, that looks like it's in quadrant 4. So I claim that this is in. So in is like a C with a line. It looks like it's an E, but it's a C with a line. That's the way we write it. So let me move this to the left a bit. This is in. And the way we write quadrant 4, Q1V. So the point 4 comma negative 3 is in quadrant 4. Okay, so let's do another example. So which quadrant does the terminal side of theta, so which quadrant does the terminal side of theta lie in? If cosine of theta is less than 0 and tangent of theta is less than 0. Okay. So, well, let's take a look at this. What do we know? We know that cosine of theta is x over r. C comes before S, so x comes before y. I think I've got that right. So if cosine of theta is less than 0, meaning negative, what that means, let me do it this way, less than 0, that means that, or that implies, double right arrow means that implies that x has to be less than 0, meaning x is negative. So we can put a negative sign over it. Okay, tangent, however, tangent of theta is y over x. It's going to be y over x. And we have that that is also less than 0. But since x is less than 0, y has to be positive, because two negatives would make a positive. So in this case, we have that y must be larger than 0, because we have x being less than 0 up there. So that means that y is positive. So these two together if I have x comma y, let me color code x comma y, where x is negative and y is positive. Okay, so x is negative and y is positive. That looks like we're in quadrant 2. So the way we would say that, this must be an element of quadrant 2. Okay. Okay, so let's note something. Do I want to, let's do sine. No, we'll do cosine in purple. Yeah, I've already used it. Okay, so cosine of angle theta in quadrant 1 would be positive, right? Because it's x over r. And in quadrant 1, x is positive. Sine of theta, which is y over r, in quadrant 1 is also positive because y is positive. Okay, well, let's look at cosine of theta in quadrant 2. Well, in quadrant 2, x is negative, so this will be less than 0. Then a sine, which corresponds to y over r, is still positive. Okay. Actually, let me move these up to be in the same spot, something like that. Okay, so now let's look at quadrant 3. So if I look cosine of theta, well, both x and y are negative, so these are both negative. So cosine is negative, and sine will be negative, corresponding to x and y respectively. And finally, in quadrant 4, cosine of theta has a positive x, but sine of theta has a negative y. The radius always being positive, I don't need to consider it. Okay, so the way people like to give this acronyms is that all trigonometric functions are positive in quadrant 1. Then we have sine is positive in quadrant 2. Then, do you agree that negative divided by negative is a positive? So tangent is positive in quadrant 3. And last but not least, the only guy positive in quadrant 4 is cosine. So, in the counterclockwise direction, which is positive for an angle, all students take calculus. If you care to learn that acronym, I'm not a big fan of acronyms, but you can just learn it by knowing what the SIGNs are for each angle. Okay, so definition. Now notice I'm going to have to distinguish between SINE, SIGN, etc. Definition. So if the terminal side of an angle theta, so if the terminal side of an angle theta, an angle theta is coincident with the x or y axis, so is, let me say, flush, meaning on, i.e. on the x or y axes, then the angle is termed quadrantal. So then the angle is termed or called quadrantal. So that's what we're defining, quadrantal. Okay, and let's recall something important from all of math. So hopefully everyone knows this, and let me do it in hot pink because it's so important. So recall the 11th commandment, as I call it. Thou shalt not. Thou shalt not divide by 0. Okay, that's the 11th commandment. Hopefully everybody knows that commandment. Okay, so let's consider the quadrantal angles. So consider x and y coordinate axes. So let me draw that. Why do I always do it off? Yeah, that's okay. Hopefully that looks okay. So x and y coordinate axes. Let's consider points. So let's call this point on the x-axis r, 0. Then let's call this point here on the y-axis, let's call it 0, r. And then let's call, maybe I'll use pink, this point here on the negative x-axis, let's call it negative r, 0. And then let's go down here, and you might say I thought r wasn't negative, and you're right, but that is the x-coordinate corresponding to r. So now down here, and x can be negative, it just has the same value as the radius, but it's in the negative direction. So this here would be 0, negative r. And the same goes for the y-coordinate. If the y-coordinate has the same length as the radius r, but is in the negative direction, we say negative r. So these correspond to, and this is the most important part. So let me, what color should I use? Oh my goodness, which color? Let's use blue. I like blue. So remember, we start on the positive x-axis, so that is 0 degrees, or 360 if we go full circle, but I'll just leave it at 0 right now. So the positive y-axis, and of course I don't have enough room, so let me move this down a bit. The positive y-axis is 90 degrees. That's degrees from the positive x-axis. So the negative x-axis is 180 degrees. That's a straight angle from the positive x. And finally, down here at the bottom would be 270 degrees if I had enough room to write it. Okay, so hopefully that's making sense. Because now we're going to evaluate the trigonometric functions, so the 6 trigonometric functions of each of these quadrantal angles. Okay, so for example, so evaluate the 6 trigonometric functions at the following quadrantal angles. Following quadrantal angles. Oh, wait. Quadrantal angles. Okay, so number 1, let's have theta be equal to 0 degrees. Okay, and I'm just going to do this monochromatically. Okay, so sine of theta, which we know was be y over r, that's 0. Well, let me write it out, y over r. So that's going to be 0 over the radius is still r in each of these cases, because the radius is the distance to the points. And the distance is always the same, radius, r. But the coordinates might differ. Okay, so it's going to be 0 over r, which is going to be 0. However, cosecant, which is a reciprocal to sine, because sine begins with an S, so his reciprocal cosecant begins with a C, well, that's going to be r over y, which is going to be r over 0, and thou shalt not divide by 0. So the annotation for this is DNE, meaning does not exist. Thou shalt not divide by 0. Okay, so the next will be cosine of theta, which is x over r. So at 0, actually, oh shoot, I've got theta. Theta's 0 degrees. Why am I putting theta? I know exactly what it is. So let me write in what theta is. 0 degrees, 0 degrees, 0 degrees. Yes, I did define theta to be 0, but I want to actually physically put it in there. Okay. So if I look at 0 degrees, the coordinate x comma y was r comma 0. So I claim that x was r and the radius is r. So that's just 1. So the reciprocal to cosine, since cosine begins with a C, his reciprocal begins with an S. So this is just regular secant, which is r over x, which we found to be r over r, or 1. And that is indeed the reciprocal of 1. And now tangent of 0 degrees is y over x, which for us is 0 over 1, which is 0. And the reciprocal to tangent is cotangent of 0, will be x over y, which is 1 over 0, and thou shalt not divide by 0, so this does not exist. Okay, let's do the next quadrantal angle, which is 90 degrees. So number 2, let's have theta be 90 degrees. Degrees, why is my degree symbol so large? Okay, so we have that sine of 90 degrees will be, well, sine is y over r. So if I look up at the 90 degree guy right here, we have x is 0, y is r. So this is going to be r over r, which is just 1. And the reciprocal, s's and c's go together. So cosecant of 90 degrees is going to be r over y, which is r over r, which is 1. And yes, that is indeed the reciprocal to 1. Cosine of 90 degrees is going to be x over r. Well, the coordinate x at 90 degrees was 0. So that's going to be 0 over r, which is 0. The reciprocal to cosine, since he begins with a c, is secant, beginning with an s. So secant is going to be r over x, which is r over 0. We know that thou shalt not divide by 0. So this does not exist. Thou shalt not divide by 0. Okay, so now tangent of 90 degrees is just the quotient of the two guys above that, namely y over x. 1 over 0, but thou shalt not divide by 0. So tangent of 90 degrees does not exist. The reciprocal cotangent of 90 degrees, which is going to be x over y, is going to be, what was x? X was 0, y was 1. Well, that's just 0. Okay, next one is 180 degrees. So let's look at theta equal to 180 degrees. So sine of 180 degrees is going to be y over r. So let's look at 180. So y is 0. So 0 over r, which is just 0. The reciprocal to sine is secant. So secant of 180 degrees is going to be r over y, which is r over 0, and thou shalt not divide by 0. So this does not exist. Now cosine of 180 degrees is going to be x over r. Okay, so the x-coordinate at 180 was negative r. So this will be negative r over r, which is negative 1. Oops, and the reciprocal to cosine. Oh, am I an idiot? I am. Why do I keep on writing the wrong things? Oh, my goodness. Okay, s's and c's go together. Oh, my goodness. Clearly, do as I say, not as I do. S's and c's go together. S's and c's go together. The reciprocal to sine is cosecant. The reciprocal to cosine is secant. S's and c's go together. Yes, I should always say that so I don't make the mistake. So this is now r over x, which is going to be r over negative r, which is negative 1. There, that works. Holy free holy, get on it. So tangent of 180 degrees, let's see if I can do this one right, is going to be y over x, which is 0 over r, negative r, which is 0. Okay, that's okay. But what's about the reciprocal cotangent? Cotangent of 180 degrees is x over y. So that's negative r over 0. But thou shalt not divide by 0, so that does not exist. Okay, let's see. Make sure I got all my S's and C's together for the other guys. Okay, good. Just making sure. So I got to say it aloud or I'll mess it up. Okay, must say it aloud. So now let's do theta being 270 degrees. So that's the south. And this one, let's use green. Okay. So sine of 270 degrees, well, sine is y over r. So at 270, y was negative r. So negative r over r is negative 1. The reciprocal, s's and c's go together. Cosecant of 270 is r over y. So that's going to be r divided by negative r, which is negative 1, and that is indeed the reciprocal to negative 1. Cosine of 270 degrees is x over r. Okay, so 270 degrees has an x-coordinate of 0. So that's going to be 0 over r, which is just 0. However, when I take the reciprocal, s's and c's go together. So this is now secant of 270 degrees. That's going to be r over x, which is r over 0, and thou shalt not divide by 0. So this does not exist. Okay, last but not least, we can do this, guys. So tangent of 270 degrees will be y over x, which is going to be, negative r over 0, which does not exist. Thou shalt not divide by 0. The reciprocal to tangent is cotangent. So cotangent of 270 degrees is going to be x over y, which is 0 over negative r, which is 0. So that's just fine. Okay. So there we are. Let's note something, not about this in particular, but just an added note. So note. So for all, that's on your symbol sheet. For all is an upside down A. So for all theta strictly greater than 360 degrees, the terminal side of theta, so the terminal side of theta is coincident, which once again is flush, i.e. flush, that is, i.e. it est, flush with, let's call it phi, some other Greek letter, where phi is going to be theta plus or minus 360 degrees times k, where k is an element of the integers. So where k is an integer. So these are all on your symbol sheets. So hopefully you'll get to know those. Okay, so for example. So let's determine the quadrant in which the following lie. So determine the quadrant in which the following terminal sides lie. In which the following angles lie. I'm just going to write it like that. Terminal side sounds funny. So determine the quadrant in which the following angles lie in standard position. Okay, so number 1. If I have theta is, say, 400 and... let's do 420 degrees. Okay, so what I want to find is the equivalent phi, which will be theta. So 420, that's larger than 360. So let's subtract 360. So what's the difference between 420 and 360? Well, it looks like 60 degrees. So where is 60 degrees? That's in quadrant 1. So that would be in quadrant 1. So that's an element of quadrant 1. So number 2, actually I might go to the next page. Number 2, let's have theta being 1225 degrees. Once again, let's find phi, some angle phi. Well, 1225 is definitely larger than 360. So how many more times 360? So 360, 720. So if I add 360 to 720, well, 300 would be 1020 and 60 would be 1080. Okay, so let's try this. Let's do 1225 minus 360 degrees times some integer k, that integer being 3. So what does that give us? That gives us that phi is going to be 1225. So that's what I mean by the integer k. So 1225 minus, what did I say it was? 1080? 1080. So I get that phi is going to be, well, let's see, if I subtract 80 from 225, that's 145, right? 145 degrees. Okay, well, that's between 90 and 180. So I claim that that's in quadrant. I guess I'll stick with, that's going to be in quadrant 2. Okay, so number 3. Let's say I have that theta is now negative. Let's have it be negative 150, so now I'm going to have to add to get to phi. So this time, what color should I use? I guess I'll use orange. So I want phi to be theta, which is negative 150, but in order to get to between 0 and 360, I have to add 360. Okay, so if I add 360, or if I just take 360 and subtract 150, I should get 210. So 210 degrees is between 180 and 270. So I claim that this is in quadrant 3. And last but not least, let's have theta be, what should we do? Negative 690 degrees. Okay, so in this case, phi will be a negative 690. So I'm going to have to add 360. How many 360s? Well, if I just add 1, that's not enough. But if I add 2 360s is 720, so that should do it. So phi is equal to negative 690. Well, 2 times 360 is 720. So what's 720 minus 690? Well, that's 30 degrees, right? 30 degrees. Well, 30 degrees is in quadrant 1. Notice phi, 30 degrees, is not the same as negative 690, but they have the same terminal side. Okay. So hopefully this makes sense, and hopefully you don't make my silly mistakes. Remember, S's and C's go together, and I will see you guys in the next video.